even exist or whether it be destroyed by the red giant, humans will very likely evacuate some of the outer planets and their moons. Mars will probably be too hot to support life, but maybe Jupiter and its moon Europa could support life, or Saturn and well, okay, not Saturn itself, but Titan. Titan is its most notable moon, and it has an atmosphere, not exactly like Earth's, pretty similar. So, when the sun is on the verge of dying, it will actually explode into a gigantic planetary nebula. I don't know why they call it planetary nebula, because they're not planetary, but it'll eject its outer layers into the galaxy. So what's going to be left is a white dwarf. It's going to have between 50 to 60% of the mass of the sun, but it's only going to be as big as, like, it's like the same size between Earth to Neptune, because Neptune's about like 4 times the size of Earth, so somewhere's that range. Those are main sequence stars, right? That's how they... The giant stars, this is where it gets interesting. So with giant stars, like a good example for that would maybe be either Chi Cygni or Betelgeuse. That's a good one. Don't say its name 3 times. You can say, you know, maybe name 3.
Betelgeuse.
But Betelgeuse,
yeah, that's a
that
major
thing is
star.
actually a supergiant. If it were basically in the spot of our sun, it would eat every planet out to Jupiter. So I don't even know if our solar system could survive much longer, because stars like that have such powerful gravity.
Hey, isn't Betelgeuse the one that's going supernova now?
It could actually. Now, it could literally happen tonight, or it might not be for another 10,000 years. We're not sure. But here's the thing. I don't know for sure, but I think Betelgeuse like a few 100,000 light years away from us. I'm not sure, but here's the thing. If a star were to blow up right now and produce a supernova, which can outshine the entire galaxy, here's the thing. That star actually already blew up. Take, for example, it's 500 light years away from us, right? It already blew up into a supernova 500 years ago. It's just that light is taking so long to reach us, so we're now finally starting to see the supernova, if that makes sense. Does that make sense?
Well, if the speed of light is constant through a vacuum, I don't know. That's theoretical.
All right, yeah. I get
you know, we've done tests, but they've all been terrestrial tests. So the speed of light could break the quote-unquote speed of light.
That's true. I would believe you there, but
everything's based on that measurement as a standard. But if you question that, then we don't know how fast the light is moving, because there's some discrepancies about the size of the universe that they're calculating. It doesn't really match up with the age of the stars that they're saying.
Oh, that really
so
is a good argument
that
there.
contradicts itself, and I've been looking into that lately.
That is a good theory right there. I really like it, but I do quickly want to finish my talk on stars. So, giants or supergiants, what happens is they only live for like a few, like, you know, maybe 200 to 300 million years, like the most about 900 million to 1 billion years if they're the smaller ones. But so what happens when they die is a bit different. They are much more massive than our sun, at least 9 or 10 times more massive, and basically they'll actually create a giant explosion known as a supernova. And a supernova, what happens in those? One of 2 scenarios. First off, the star will turn into a neutron star, and they are incredibly dense. Like, if you were to actually take a piece that size of my cell phone, it would weigh about the same as a small elephant. It's incredibly dense shit.
Yeah. The only thing that's more dense is a black hole.
Oh, dude, they are extreme. Not even light can escape from that. But that's scenario 1. Scenario 2, which what happens more often, is the star completely blows up in that supernova. What it creates is a black hole and 2 or 3 new beams of energy called gamma ray bursts, and they are incredibly powerful. In terms of raw energy and power, they're actually second only to the Big Bang itself, at least as the 2016 statistics.
Yeah. Now I always get confused between the pulsar and the quasar. Which one is like the neutron star, the pulsar or a quasar?
That's the one thing I actually don't have the answer to, guys. I wish I could, but that's the one thing I have the answer to. But either way, so that's the interesting thing about stars, and there's even more I could go into. But the big thing is, you know, the stars that are like red and orange are usually dimmer, while yellow and white ones and blue, they're the brighter ones.
Yeah.
But here's the thing. If they're little dwarfs, even if it's a white dwarf, even though it's bright, it's still pretty dim because it's small. But red giant, like red and orange giants, they're super bright. Even though they're dimmer colors, it's because of their immense size. So yeah, stars are very interesting things. I'll tell you guys right now, there's actually a couple of documentaries on YouTube I've watched a few times now. The first one is the time lapse of the universe, which explains everything from the Big Bang to today. And the second one is time lapse of the future. That explains everything from now to how we believe the universe will die. Because remember, this is what we believe at the moment, but there's a good chance many of it can change because that's not science, right? It's ever evolving and changing facts.
Yeah, it changes a lot, the cosmology. I wouldn't even get into the latest debates that I've been studying, but what can you say about the colors of the stars? Because you haven't mentioned a green star.
Oh yeah, so
why is there...
Get this, green stars, there's actually no such thing. Because remember, like, now the sun, its main color or peak is in the yellow spectrum, right? But it also shines a little bit of each other color. So a little bit of red, orange, a little bit of green, blue, and purple, right? But it's mostly yellow. So here's the thing with green stars. Since they're like right in the middle of the spectrum, they actually, I think, appear as white. So Raj, he could give you a much better take on it than I could. But I'll tell you right now, the big thing about stars is, how can I put this? So yeah, green stars, you can't really see them like that, but their light can be a little bit distorted through atmospheres as well too.
Okay.
So you know, it mostly appears like to me, whenever I've like seen the sun through like the very side of my eyeballs, it's usually looked like white. I don't look directly at it because I don't feel like going to the doctors. Healthcare's expensive these days.
But you need the like watching an eclipse.
Yeah,
solar eclipse. You could put on the
what you call it?
filters.
You remember the big one last year, right?
Oh yeah, I've gone to see a lot of them.
What you call it? As for me, I was up in Plattsburgh watching it.
Yeah, that one was pretty incredible.
Oh, you betcha it was. There's gonna be one next year.
That had the ring around it.
Yep.
The ring of fire.
That was the total eclipse. There's 3 types of solar eclipses. There's total, partial, and annual. An annual eclipse is basically like a total eclipse, just the ring is a bit thicker, you know?
Yeah.
And then as for lunar eclipses, there's also 3 types. There was a total one back in March. I even had pictures of it. I'd show you guys, but it's on my laptop, unfortunately. And I don't know if we're really gonna get service out here or anything.
Wow, we're on the
But yeah,
other
when
end
it
of
comes
the
to
campus.
close to stars, the thing is that like this is actually something I pre-learned interesting myself last year, is that stars, like, there's actually like the 7 main colors we know of. You know, there's red, orange, yellow, green, blue, purple, and pink. Now, of course, there's also like the neutral colors: black, white, gray, and brown. But like the 7 main colors on that spectrum, well, Raj said there's actually even more. There's more colors on the spectrum. Our eyes just cannot deceive them or make them out. So that's the thing. I've seen some pictures of nebulas that NASA captured with their really cool scopes and all. The thing is, if we were actually able to go to outer space, travel the tens of hundreds of light years to get there and see them, we wouldn't maybe see them exactly as we see them in the pictures, because when the space scopes take those pictures, they like color code the things, right?
Yeah,
so
NASA
we
always
would
does
see
that.
it, we just wouldn't see it with those exact colors, I think.
Yeah, you have to read the information on the thing, how they colorize it. Say, oh, this is not visible in our visible light.
I mean, we could see it just, again, now with those exact colors, I think, is, of course, you know, again, the problem is they're all very far away. That's the part that sucks. I love the cosmos, but in terms of actually exploring it, that would be very difficult, because the closest star to our solar system is like about 4.5 light years away. And that's if we were going at light speed. That's how long it would take. So with our current technology, I would say nothing under 30 to 40 years at least.
Oh, is that Proxima Centauri close to Alpha Centauri, A and B? There's three.
Sure,
there's 3 of them.
I believe so.
Fairly close.
Yes, good job on bringing that up. But hey, I like where this is going. But you like my little discussion?
Oh yeah.
Yeah, what you call? I could have also told you about what's gonna happen like in our solar system and universe the next, you know, couple billion years. But like, again, if I were you guys, try check out the videos I talked to you about on YouTube. They're actually really cool documentaries.
Oh, I could search those out for sure.
And
do you make videos on there?
I do. I used to make videos on YouTube, not much anymore. And I usually made like war scenarios with mapping, but I really don't do that anymore. 1, because I don't have the time, because, you know, college work can be demanding. And 2, I don't know, I feel like
Oh, so you've done some like war scenarios, military.
Yes, but I've never really done
Okay.
like anything cosmic related. But
Uh-huh.
here, real quick, while we wait to go and use the telescope to view some stars. Let's see, where the hell's my phone? There it is.
I hope my sugar doesn't go low because I didn't bring anything with me.
That's why I was asking you before we went. I said,
I think I'll be okay, but
Yeah.
never know.
Okay. So maybe we should head back sooner, right?
My sugar's 200 right now, so it should be fine.
Yeah.
So what do you think about aliens?